secondly, already kind of talk about that molarity slightly. So we know what is molarity. Molarity is represented by the letter M, and it stands for mole over liter. Okay. Now, when they say mole over liter, the mole here is a mole of, guys, girls, solute, and the liter here is a liter of solution. Okay, solution meaning solute plus solvents. Although most of the time your solute doesn't really change your volume of the solution by that much, so we can kind of ignore it for the most part. Now, concentration can be measured in terms of molarity. Okay, so this is the word that we're using for. Now, obviously, if I want to find mole, you guys been doing this before, that is going to be molarity times volume, right? Because liter is a volume, so molarity times volume will give you mole. Okay. Dilution problem. Dilution problem is this. I can tell you that I have, I don't know, 3 molarity or 3 molar, not sodium, 3 molar hydrochloric acid, right? 3 molar hydrochloric acid, that's very strong. To do the lab, I want to dilute it to 1 molar solution. Okay, and I want to make 100 milliliter of 1 molar solution. How would I do it? How much 3 molar solution I need to use to make 100 milliliter of 1 molar solution? Okay, so that would be the dilution problem. So to do the dilution problem, all you do is this. You're gonna do molarity times volume is gonna be equal to molarity times volume. Because remember, the amount of solute that dissolves in the liquid doesn't change just because you are diluting. Because the amount of your stuff is still the same. You just mix it with more water, so you have like more water in this sense. So you're doing concentration times volume is equal to concentration times volume. Some people say CV equal to CV. I say MV equal to MV. So we're gonna say 1, 1, and then there's 2, 2. Okay, molarity can be used as conversion factor also, right? What I mean by that is conversion factor to convert moles to liter, right? So if I give you some kind of solution, I give you moles, and I want you to find liters, or I give you liters and I want to find moles, you could convert it if you have a molarity value. So let's take a look at this. Some of the question here, calculation should be very, very simple because you've done them before. Okay, so let's take a look. If 6.73 gram of Na2CO3 is dissolved in enough water to make 250 milliliter solution, what is the molarity of sodium carbonate? Well, should be really simple, right? What is molarity? We said that molarity is moles over liter. Now look at the question. Did I have mole?
No.
But can I find out?
Yes.
Yes, because what did I have? Gram. I got grams. Can find moles. Agree? Okay. Did I have liter? Yeah, kind of. I have milliliter there. I could convert it to liter. Here's a 2-way I'm gonna do it. One other way I like to do is I like to write everything in one thing to look it up. So here's what I usually do, or how I write things. I would say 6.73 grams. I don't want the grams. This is Na2CO3. I don't want the grams. So gram go on the bottom, mole go on the top. That's 1 mole. That's still Na2CO3. Okay. Na2CO3. You're going to have to figure out that number. And then what happens is, you will notice my gram will cancel out. I have mole. I don't want a mole. So I'm going to say time. You can say 1 divided by, if you want. You can say 1 divided by 250 milliliter. And I don't want a milliliter. I can say 1,000 milliliter is 1 liter. So pretty much kind of makes sense that this is kind of like, in a way, a stoichiometry kind of or dimensional analysis way. I just cross in the unit. You guys see that? So I'm just crossing the unit that I don't want and leaving me with the unit that I want so that I get mole over liter at the end. Or you can solve this two separate thing. You can solve it two separate thing as it is. You can say 6.73 gram is, grams to mole, and then therefore you're gonna get the mole, and then you can say 250 milliliter is basically 0.250 liter, and then you can say, well, molarity is equal to mole over liter, and then solve for that, and then you're gonna get a molarity. So you can also do it.
Oh, you have to solve it.
Yeah, you gotta solve it. I haven't solved it yet.
Oh, I see.
Right? So, or you can also do it this way, right? So I don't have my sodium carbonate yet. So my sodium carbonate is 22.99 plus 12.01 plus, oh wait, 22.99 is time 2. 03. So that get you 105.99. Hopefully that was correct. Do you guys see the difference? It's pretty much the same thing, except I usually like to go everything at one time because the moment I grab a calculator, I tend to forget what I'm working on. .398, basically saying 0.24, 240. Wait, no, I mean what am I writing? 0.254 molarity. Skip one number, okay? Or 0.254. Now, you can say molarity or you can say mole per liter, the same thing. Do you guys see what I did? Right? Instead of solving one line, I can make it 3 line and solve for it. Whichever make you feel comfortable at solving, you can do it. Okay? One other thing, like I said, I like to do was I just like to cross down the unit, go from left to right, and then that's gonna solve the question. Anyone has a question? Okay. Do the next question. Next question is asking for grams. Can you guys figure out, I don't care what strategy you use, let's figure out if we can find grams from my giving information. Can we do that? Let's try it. So you get molarity, you get this, let's try to find it. Okay. And now I'll give you guys the answer to see if we get it right. Definitely show me your work, and when you're also working in class too, please show work. I know sometimes it's easier not to show work, but show me your work.
Let's see.
Let's see if you guys can.
Oh, man.
Do we got that answer? 0.494. Yeah?
Wait, almost.
Wait. Okay. And then continue on the next one.
No.
No? Oh no.
Wait, how do you do that?
How we do that? Well, let's go back and look. What does big M here stand for?
Moles are liters.
Mole over liter. Okay. What is this?
Yeah, liters.
Okay. Can we find moles out of this? Yeah.
What is your M on the top?
Hmm? You gonna use that? Which M?
Wait, how do you write it out?
For which one? This thing?
Yeah.
Yeah. 0.0125. Yeah, because this is M. So mole over liter, right?
And your liter's only 0.25, right?
Right. Liter is only 0.25,
Multiply the other thing by
Liter?
51.
right? So that will go out. Now I have mole. How do we get grams? Molar mass. Time molar mass. 1 mole. Okay, and I believe my molar mass is 158.04. So if you've done this, you get your grams of 0.94. Good. Now, you don't necessarily have to write everything in one sentence. Like I said, you can break it up if you guys want to, saying solve for mole first,
Oh,
and
okay,
then
okay.
solve for gram.
I multiplied instead of divided.
See, careful. Multiply, divide.
So when you see liters and then moles, and then molarity, then you multiply them.
Yes, because remember, molarity is mole over liter. Okay, continue on. Let's try number 3. What is the volume? Now, careful. I want milliliter.
Shouldn't it be 495?
No.
Maybe I did wrong.
I don't know where you have that quote from.
Oh, manganese. Oh, my.
Yeah, slightly. Yeah. Okay. Let's do another one. How do you find volume? Well, in this case, again, you can do it at one step or you can do multiple steps. So what is molarity? Mole over liter, right? What is this giving you? Grams. This is asking for volume. Okay. You can still set up in one long equation if you want, or you can break it up. Here is how you're going to do if you're going to break it up. You notice that this is gram, this one has mole. Guess what? Convert that gram to mole first. So you're going to say 25.0 gram of NaOH. Converted to mole. 1 mole of NaOH is the gram of NaOH. We're going to solve for that. You're going to get the mole of NaOH. Now you have molarity, it is backward. You want to find volume. So how would you find volume?
You divide
your mole by the molarity. Right. So you're going to say to find volume, you're going to do mole divided by molarity. So that's what you're going to be doing. So whatever mole it is, you're divided by 0.123 molarity NaOH. Now, can you do it a different way? Yeah, you can do it a different way. So this one, I do it multiple step. I also sometimes like to do one step. Here's how I do it. I notice that I want to look for milliliter, right? Notice that this is going to give you liter. Well, this is going to give you liter to 5 milliliter. You're just going to
divide by 1,000.
Yeah, well, yes. Okay, now here is what it's going to do. I can show you guys one step that what I'm going to do is a long way. I'm going to write it up here, okay? Because there's a room up here, so I'm going to just write it up there. So here is what I'm going to write. See, molarity is mole per liter. I'm going to flip-flop it. So I'm going to say 1 liter is 0.123 mole. Agree? Can I write it? Yeah? Okay, now then I notice that I don't want that liter, so I'm going to say 1 liter, 1,000 milliliter. Agree? Now what I'm going to do is I don't want that mole, so I'm going to say 1 mole gram NaOH. Do you see what I just did?
Wait, how do we have liters divided by moles?
Molarity. I just write it upside down.
What? You can do that?
Yeah. Because, take a look. Because when I say, for example, let's say I'm going to say 5.0 molarity, right? Then that means it is 5.0 mole over liter. Okay, which means 5.0 mole over 1 liter. So therefore, I can also say 1 liter is 5.0 mole.
Oh, we're not dividing. This is like a ratio.
Yeah, it's like a ratio.
Oh, I see.
See how it goes? So that's just the example. So you can also solve it this way. Question about this? Fairly easy, right? How to do this?
Wouldn't that give you like milliliters
Oh, yeah, that you're right. It will give you milliliter over gram because I still have gram. So that's where I had to use this. Time 25.0 gram. See how it goes? Yeah, this is why important to you to go back there and check it. So this is why I always do this when I'm solving for things. So I don't accidentally leave some unit behind. And I leave behind the unit that I want, which is a milliliter. Right? So that's gonna give you milliliter, which is what I want.
Oh.
See how it goes? Yeah. I prefer this method better than doing this. Because when I do this, I tend to forget that it was in liter and I need to convert it to
But
milliliter.
either way, on the AP test, it's fine.
It's fine. They will take either way. That's being said, they need to be able to look through what you did. So I don't want you guys to write just 1 over 1.123, time 1,000 divided by something. Don't write this. That's too messy. Write it down with a unit so at least you can check it. The grader can check it. So that's where, like, if you accidentally write the wrong number, we can tell. We're looking at it. We're like, oh yeah, it's fine. They just write the wrong number. Okay. For instance, I can tell you that, guys, that a lot of you guys, for question number 4 on the APA's, the free response, this one, right, when we're doing it, a lot of you guys got in trouble for number, not number 4, sorry, number 3, got in trouble for part C. You guys have no idea how to solve for this. But part D require part C. So guess what? As long as you have something on the part C with the answer and you use that answer to successfully do part D, you get credit for part D.
Even if your C is wrong?
Yeah, even if your C is wrong.
Oh.
But that being said, if you don't show me any work and you just give me the answer on D, I have no way of figuring out what you did. You didn't get a point for part D either. Does it make sense? So I need to be able to tell. This is why grading these free response is taking forever, because I need to be able to figure out what you guys are writing there. Okay, you need to show me all your steps so that we can see. If you would just say 1 divided by 0.123 times 1,000 divided by something times something, let's say that is really difficult for me to see because, one, I don't have the unit. So let's say you, instead of writing 0.123, let's say you said 0.25 or something, I wouldn't know what you did. I would be like, okay, like I see the number, I don't know where they're coming from. But at least like if you have like something in there, I can say, okay, yeah, you just pick up the wrong number. Make sense? Because I think earlier somebody picked up the wrong number and then I saw it right away. I'm like, okay, you have the wrong number because I can see it. You have word. Okay. So, question? All right. So I'm going to stop there.